Hey there. Here's a lesson on differential equations. This is Unit 7 of the AP Calculus AB curriculum. Um, in this lesson, we're going to talk about how to draw slope fields, how to solve separable differential equations, and also reinforcing some skills that you should already have learned from prior units, especially units 2 and 3 on derivatives. Um, how to interpret verbal descriptions of changes of separable differential equations. Remember, um, rate of change is the derivative. Um, and also, you'll be working on problems involving models for exponential growth and decay. You'll see some differential equations that involve that. And this is about 6 to 12% of the AP Calculus AB exam. So let's talk about the plan for the lesson. You and a partner will be working on a few items. The first item you'll work on will be this link here. This is where you have to graph the derivative of a function, something that you should have already mastered from a few months ago. But it's a skill that you'll need to utilize when drawing slope fields, which you'll see in just a few moments. This is a pretty fun activity because what you get to do is you get to see how accurate you are drawing the derivative from the original graph. The solid black curve is the original function. The curve of the dots that looks kind of bluish is going to be the derivative. So you'll need to move these dots around so that you're actually getting the proper slope at various points, which will help you draw slope fields in the next activity. We'll see how I do. I'll do one of these. And if you can actually beat my accuracy score, I will reveal an embarrassing video that I have somewhere hidden in my YouTube library. So if anyone can beat my accuracy, you get to I get to embarrass myself. So let's see how we do here. So if you look at x equals -6, clearly the slope is positive, and it's probably a slope of 2. So I'm going to push this up to about 2. Remember, the outputs for the derivative graph is going to be the slopes of the original function, the slopes of the tangent lines. At -5, it looks like the slope's getting a little less steep, probably about 1 or so. And then we definitely have a peak at x equals -4, so the slope is going to be 0. Then it's negative, probably about -1 at x equals -3. And it probably gets a little more steep, probably around -2 at -2 for x. At -1, it's probably about the same steepness at negative as -2. At 0, it's getting a little less steep than 0 at 1. At 2, it's probably about a fraction, maybe about half as the slope there. At 3, probably about 1. 4, probably about 1. 5 is getting a little less steep, and 6, probably slightly negative. Check your accuracy, 84%. Here are the results. So I'm pretty sure someone's going to beat me. Someone's going to go over 90%. So I'll prepare a video for you guys to watch after we're done with all this. So after you and your partner do that, and I'll ask you guys to do it twice, and then average your accuracy and see who got a better score. You'll do this in a breakout room. Afterwards, you'll work on this worksheet, and I'll share all the links either in the chat or I'll put it in the or email it to everyone or whatever online learning platform we're using. This is just 4 questions. Should take about maybe 10 minutes. Should spend about 10 minutes on this activity, then 10 minutes on this. Here, you're just asked to graph a slope field. So, for example, your derivative is dy over dx equals x. So when x is 1, the slope is 1. So you're going to draw a slope of 1. Or when x is 2, then the slope is 2. And obviously, there's no y on the other side. So y doesn't have an impact on how you draw the slope fields. And then here, you actually have the slope field. But what you need to do is you need to match the slope field with the differential equation. So I'll let you guys think about strategies you'd use. One hint, you may want to look where you have 0 slopes, and maybe where it's positive and negative, and go through process of elimination using good test taking strategy. The answers are on the following page. Once you do that, then you're ready to learn about separable differential equations. So this is a great video where you could watch this video to which discusses how to solve separable differential equations. There's a bit of algebra. This is an application of the integral, so you'll be using an integral as well. And a pretty short video. Once you're done with that, you and your partner should discuss it and then work through the examples on this next link. This is from Paul's online notes, which is a fantastic resource for calculus problems. It does explain the process. It'll reinforce what you saw in the video. And then there are examples that you can work out. If you get stuck, you can look at the solution, try to reverse engineer it, and then and obviously try doing it without looking at the solutions for the other 3 examples. Don't do examples 5 and 6. It's a little bit complicated, but examples 1 through 4, I think, are good ones to do. By that time, we'll be done with class. I expect you guys to spend about 20 minutes on these examples because you do need to spend about 5 minutes on each one. Once you're done, then I'll ask you guys to complete this Google form where you just talk about reflecting on your experiences today with all the activities and how confident you feel about this topic at the end. And this will be good feedback for me because there are some things I need to discuss or reinforce during our next time we meet, I will take care of that. And that's what we'll be working on today. And I'll be available to help you guys out when you guys get stuck or just to see how things are going or give some feedback.